Hello, this is Mr. Collier, and today we're using the power rule of differentiation. Okay, so let's look at the old quadratic, and we're going to derive a formula for the derivative, basically, in a second. Um, Here's some notation, first of all. So sometimes we use this notation for derivative, dy by dx is pronounced, or sometimes we have f prime of x, or just y prime. This one here is a bit rare. Okay, so let's look at some examples. Let's do this by first principle. Okay, so let's do limit as h tends to 0 of, so remember we do f of x plus h minus f of x over h. So limit as h tends to 0. Let's substitute in x plus h, and we got 3 times x plus h squared minus 3x squared over h, which is the limit as h tends to 0, 3 times x squared plus 2xh plus h squared minus 3x squared over h. So we've got just 3x squared plus 6xh plus 3h squared minus 3x squared over h. And these cancel, and the h's cancel, and we're left with just limit as h tends to 0 of 6x plus 3h. Now we can just substitute in 0 for h, and we've got just 6x. So you see there is a shortcut way of doing this, right? You can just take the 2 and multiply it by the 3 and reduce the power by 1. So you get 6x is the derivative. Okay, you can prove that if you just use first principles with the ax squared plus bx plus c. You can show that the derivative is just going to be 2ax plus b. Okay, I'm not going to bother going through that because that'll take a while with a lot of algebra, but this is what you get. Okay, so in general, if you have any exponent or x to the power of any number, you're going to get n times x to the power of n minus 1. Okay, reduce the exponent by 1 and multiply your constant out front by the exponent. Okay, so an times x minus 1. Okay, we'll just do some examples here now. So this one here, using the power rule, we just bring the 3 down, reduce the exponent by 1. It's as simple as that. Okay, so you can go through the whole process of first principles. It would take you a while, but you would get 3x squared. Okay, so sometimes we want to rewrite them, rewrite functions with exponents instead of surds. So when we get the derivative here, we get half and reduce the exponent by 1. That means to the power negative half. Another way to write that is 1 over 2 root x, right? So that's the derivative. Remember, the derivative equals the slope at a certain point. So find the slope at this point. We just substitute in the x value into this, right? So 1 over 2 root 4, which is 1 over 4. Okay, that is the slope at that point of root x. And it kind of makes sense. This looks like it would have a slope about a quarter. Okay, here let's change them all to exponents so we can differentiate. Okay, that's 2x to negative 3 in e, and then we've got x to the power of 3 over 2, let's say 1/5. Let's write it like that. This is x to the power of 1/5, and then minus 2. When we divide, we subtract the exponents. So we get minus x to the power of 1/5 minus 2 is negative 9/5. So when we find the derivative, we bring the exponent down, reduce this exponent by 1. Here we're going to have 2 pi x. Here we're going to have negative 6x to the negative 4. E is just a constant. The derivative of any constant is just 0. You can think of it as ex to the 0, and then when you bring down the 0, you just multiply it and it's gone. Or you can think about it this way. That's just a horizontal line, and the slope of it is 0, right? Remember, the derivative equals the slope. Next, we are on this one right here. So you do that times that is 3/10 x to the power of half. And this one, we're going to multiply that by that. You're going to get positive 9/5 x to the power of negative 14 over 5. Okay, that's the derivative of that one in part A. Part B, what you can do is you can expand and then divide by x, and we'll have a polynomial we can differentiate. So we got x cubed minus x squared plus 3x squared minus 3x over x. That equals x squared. X squared, that gives you negative 2x squared divided by x gives you negative 2x squared minus 3x divided by x. Oops, let's just keep that for now. And then divide by x. Okay, so we get x squared minus 2x minus 3 is the derivative. Okay. Yeah, I should clearly label that. We didn't find a derivative yet here, and here we found a derivative, so this is the derivative down here. Okay, let's take a look at this example. We've got this function, calculate f prime of 2. So let's get the derivative. Let's rewrite the function and then get the derivative. So this is like to the power of half minus a quarter. So that is going to be a quarter. So we're going to have x to the power of a quarter plus 3, and then we got 1/3 minus a quarter. That's like 4/12 minus 3/12, so that's 1/12. Okay, when we find the derivative, we get a quarter, x to the power negative 3 over 4, plus 1/12 times 3 is a quarter, x to the power negative 11 over 12. Okay, so to get f prime of 2, we can just substitute 2 into this, and you obviously have to use your calculator, and you get 0.281. Okay, that makes sense. The slope should be less than 1 right there, right? Okay, the graph of fx is shown. Sketch what you've calculated in part A. Okay, that's basically what I've just calculated. Slope of that line is 0.281. Okay, next, find the coordinates of the point on the graph where the slope is negative 1. So we need to find the derivative, because that's equal to the slope. So we have 2x minus 3. So we just substitute that in for the slope, which is the derivative. So let's add 3 to both sides. We have 2 equals 2x, so x equals 1. That's just the x coordinate at this spot, right? So we have the x coordinate there. And we know the slope is negative 1. To get the y value, we substitute into this equation, right? So y equals 1 squared minus 3 times 1. That equals negative 2. So the coordinates of that point is 1, negative 2. Okay, because you have the slope and the point, you could even write the equation of the line, which is pretty common. That's a pretty common thing to do. Y minus negative 2 is y plus 2 equals the slope is negative 1 times x minus 1. So we can even get the equation of the line if necessary.